Okay, we're getting closer to our discussion of mastitis, and that brings us to a discussion. So, probably the first thing we need to talk about is what is milk, defined by the federal government as a lacteal secretion practically free of colostrum, obtained from the milking of one or more healthy cows. So, I think this has been expanded to do sheep and goats at some point. Um, But the big thing lately is the people that are doing plant products that are calling it almond milk or whatever milk, but we're talking milk comes from mammals. Um, and what we're going to be talking about here today is more what do bacteria do in milk? And the answer is they have a hell of a good time. It's nearly a perfect growth medium for bacteria. It's like Mardi Gras, New Year's, and Christmas all rolled into one. So, for the most part, bacteria grow very, very well in milk. Our job is to keep them out in any way we can, and that's from for a cow's health, for cleanliness of our machines' health, and for the public's health moving forward. People sometimes forget that many of the pasteurization and homogenation laws that have been put into place is because people used to get killed by milk with the TB and the listeria and all the other pathogens that used to be transmitted in milk. We've since become much cleaner, lots of testing, so there are opportunities for raw milk, but the reason we went there was refrigeration issues, health issues back in the early 1900s. So the production of quality milk, who cares? Well, just about everybody. Everybody's got an opinion. Everybody's got what they want. The consumers of dairy products, the retail distributors want those products to be sold, to be used. Milk product and milk product processors. Cleaner milk tastes better, becomes products easier, all kinds of things like that. Cooperatives, veterinarians, producers all have a stake in the production of quality milk. So just about everybody cares. So when we're talking about things living in milk, there are two different categories. There's somatic cells and then there's bacteria. Somatic cells are of the cow's body, so they're mostly white blood cells, but they'll also be the epithelial cells that slough off from inside the alveolus and end up in the milk. So those are more complex from a DNA standpoint, and a whole lot more DNA, and that's important when you're doing a California mastitis test. Bacteria are foreign to the body, foreign to the cow. They can take up residence in the milk, and depending on where they're from, what type they are, indicates different problems we might have. Let's start with somatic cell. Somatic cell count is an indirect indicator of the bacteria load. Indicate indirect indicator of mastitis. So the bulk tank legal limit is 750,000 cells per milliliter. So we've got an area the size of a cubic centimeter, a block, a centimeter, centimeter, centimeter. On all sides has got to have less than 3/4 of a million cells in it that are somatic. So it's amazing to me that it all fits in there. So mostly white blood cells. There are a lot of producers in the U.S. that are requiring less than 400,000, both from I don't want to take the other type of milk, and if I want to sell your milk products overseas or in other countries, most other countries require less than 400,000 for products coming in. On a national average, we've gotten down below 200,000. That's a function, I think, of competition and people taking this milk quality thing seriously. This is the first real move we've seen in the dairy industry. The somatic cell was more or less constant, but recently, in the last few years, it's started to drop, and that's a function of competition and what the processors are asking us to do. We look at somatic cell. Any animal below 100,000 is considered uninfected. If we have a bulk tank somatic cell of greater than 200, they suggest that we have infections in our bulk tank. Animals that have infections are being milked into the tank, and that's something we're going to lose premiums, something we try to avoid. As we get into higher and higher somatic cells, both from a tank basis and on an individual basis, there's an indication that we're losing secretory tissue. The white blood cells coming into the milk are busting through the basement membrane, knocking off secretory tissue, and that secretory tissue does not return at least till the next lactation, and we lose the potential milk production for the rest of the lactation, especially if it happens early on. And the more somatic cells we have, the more loss that we have. We showed you those charts in the fall about the percentage loss. Somatic cell, national average, low 200s. We've still got turds over 400, so there is room nationally for improvement. Measuring the bacteria directly. One is probably the most, or the first one we go to is the standard plate count, or sometimes reported as just PC plate count on a tank report. This is an estimate of the total number of viable aerobic bacteria in milk, so this is a good overall measurement. We plate the milk onto a standard petri dish, solid agar, incubate for 48 hours at 90 degrees, so warm, wet, lots of food. Things grow pretty easy. So this is used to monitor milking system cleaning practices, proper milking practices, udder hygiene, and mastitis prevention and control. So the bacteria in the standard plate count can come from pretty much everywhere, either inside the cow, from the milking equipment, or they may grow in the bulk tank. So if we're not cooling things, so the standard plate count pretty much does all bacteria from all locations. If we have a standard plate count of greater than 10,000 colony forming units, CFU, per milliliter, that is considered high. Should be closer to 5,000 colony forming units. So colony forming units is viable bacteria that can grow and multiply. So we've got 5,000 bacteria that were healthy and ready to reproduce in our milliliter. So the standard plate count can spike from anything. So mastitis, so bacteria inside the cow or inside the udder. Dirty cows, bacteria from outside the udder. Unsanitary milking practices. We're not cleaning the teats off. We're putting material into the milking machine. Failure to cool the milk rapidly allows the bacteria to grow. Lack of hot water to kill and properly sanitize. Extremely wet and humid conditions. We've got more mud, more moisture around our cows. That's going to lead to usually more bacteria in our milk. A subset or a subset of microbes or a subset of the standard plate count is the preliminary incubation count, PI. And this is an estimation of cold-loving bacteria. We're going to incubate at 55. So 55 degree is pretty much a cold room. And you're going to do it for 18 hours, so relatively short period of time. And this gives us an indication of on-farm sanitation practices and holding temperatures. The preliminary incubation count should be below 10,000 colony forming units per milliliter. If we're above 20,000, we're considered high, and 50,000 colony forming units per milliliter indicates a problem. Another subset of bacteria will be measured by the laboratory pasteurization count, LPC. These are the bacteria that might be able to survive a laboratory pasteurization of 143 degrees Fahrenheit for 30 minutes. So we don't want bacteria surviving pasteurization, or they can go on to multiply and grow in the milk as it sits on the shelf. 200 is considered high for this measure. This should be a very small number of bacteria, relatively speaking, can survive pasteurization. Coliform count, or we might just say the shit bacteria count. So estimate of bacteria that come from manure or contaminated environment. We want to grow only coliforms in that auger, so we need a special auger. We're doing, again, 48 hours, 2 days, 90 degrees, so fairly warm. We want to see which bacteria are of a manure origin. So anything greater than 100 colony forming units, and I just start to think about this, coliform bacteria in my milk, I've got poo in my milk. That just doesn't seem like a good thing. So anything that's going to introduce dirt, anything that's going to introduce manure, bedding into the milk supply is going to lead to increased coliform count. So poor milking practices, dirty equipment, contaminated water, dirty milking facilities, and animals with coliform mastitis, either clinical or subclinical, are going to lead to higher coliform counts. So those are the standard quantitative measurements that we usually deal with for somatic cell and bacteria. There are some qualitative measures of milk quality that we need to be concerned about. Flavor and odor characteristics that will influence how people react to it, how people accept the product. And this is one of the things that, at least dealing with some of the brands that you see on the shelves around here, that certain brands, they just don't taste right. Other brands taste a whole lot fresher, a whole lot more like the milk I grew up on. So if we've got feed or weed flavors, that's usually considered a negative. If we've got any sort of bad silage, that can get through. We talked about that last fall, stinky feet, the metallic, the sweat flavors that get into the milk because of bad silage. We really don't want that to happen. Cow Barney flavors due to bad environment. If we went and talked to the Juvendale, Vince and Julie, they would talk about how they never run their barn cleaner while they're milking. The idea behind that is the air gets stirred up from the barn cleaner, and that ends up in the air system, and that ends up in flavors in the milk. So they're very cognizant of what they're doing. Rancid flavors due to free fatty acids. As the fat breaks down, that gives us some bad flavors. Malty flavors, high acid flavors due to bacteria. So basically, bacteria are starting to produce the characteristics of cheese. We don't want that to happen. Oxidized flavors due to sunlight. If milk is exposed to sunlight, it will get a distinctive taste, an oxidized flavor. The clear containers are usually the culprit for those. We've started to see some more solid containers that don't let in the UV light, so that's very important. And maybe we got some contaminants in some way, shape, or form that are going to affect the taste and or manufacturing characteristics of milk. Other milk quality issues that we might run into: milk processing errors. We're mixing things, we're adding water, soap that we shouldn't in some way, shape, or form. We're not following the process the way we should, not getting all the steps right on the way to manufacturing something. And then antibiotic residues, there's just no reason to have antibiotics in the milk. Um, Nothing good comes from that as an industry or a farm, so we need to make sure that does not happen. What determines milk quality? We can talk about odor and flavor, temperature, bacteria, freezing point, antibiotics, somatic cell, acidity, sediment. Anything that isn't milk, isn't secreted by the cow. If it gets in there, if it messes things up, nothing good's going to come from that. We talk about absorbed flavors. Any of the fat soluble things will end up in the milk. They can either be ingested or inhaled. So, diagnosing the problem, I come back with a high PC or SPC count. How do I streamline my investigation to figure out where those bacteria are coming from? We talked about the standard plate count. The bacteria can come from pretty much everywhere. So how do we have a problem, we know there's something there. How do we sort through the potential sources of the bacteria? Are they coming from the cows? Are they coming from the machines? Are they coming from the way we handle the milk? And this little flow chart here from Penn State is a good way to work your way through, focus your efforts to find the problem faster. So we identify a problem. The somatic or standard plate count is too high. The first tree or first question we have is bulk set somatic cell count too high or too low. So if we've got the bulk tank somatic cell count above 250, that suggests some sort of mastitis problem. If we're below that, maybe we don't have that problem. If the PI count is less than 3 to 4 times the somatic cell, we're saying that we've got high somatic cell, lower relatively PI count. We might check our cows first. Maybe the bacteria is coming from mastitis within our cows. So lots of bacteria. First thing we need to check in this branch is the mastitis. If your PI count is really high, with that, you're going to check everything because you're probably getting bacteria from the cows, from the machines, and from the way you handle the milk, maybe not cooling it quite as fast. If we've got a high standard plate, cows that are probably not infected, but we've got a low PI count, we're probably introducing bacteria at milking. So we're not cleaning our cows off, we're milking dirty cows. We've got too much water on the udder, and that udder soup is coming down and getting sucked into the machine. So looking for bacteria entry during milking practices on this branch is where we need to go first. Last one, we've got low somatic cell, high PI. We want to check milking practices or milking equipment first. Are things as clean as they should be? Do we have some sort of problem somewhere where things are not getting cleaned like they should? So check your cows first, check everything, check your milking practices, check your equipment. So depending on where you are on these three measurements, standard plate count, full tank somatic cell, or preliminary incubation. Depending on where you are, it'll tell you what to focus on first to get that bacteria down as quickly as possible.